Building traditional quadratic equations for sequence and series questions is a massive trap. It burns through your exam clock. We are going to bypass the algebra entirely. Here are 20 master tricks that turn long algebraic proofs into simple arithmetic, starting with our calculator ninja hacks. Trick 1 is the reverse check. If you are asked to find how many terms it takes to hit a specific fraction, like moving from 25 to 0.00032, don't write out the T sub n formula. Just grab your calculator. The multiplier is 1/5. Type 25, then keep dividing by 5. Count the screen updates until you hit your target. That's your answer, 8 terms. Next is trick 2, the put n equals 1 hack. Looking at this specific question for the series 1 plus 11 plus 111, the options are massive algebraic formulas for the sum. Don't try to derive them. The sum of the first one term is just the first number. This provided solution shows exactly how to test those options by plugging in m equals 1. In option C, you get 10 squared minus 9 minus 10, which leaves 81. Divide that by the 81 outside the bracket, and you get exactly 1. It matches perfectly without a single derivation. Trick 3 is the reverse calculator. If you need to convert a repeating decimal into a fraction, skip the infinite geometric progression formula. Just divide the multiple choice options on your calculator until the screen spits out the exact repeating decimal you are looking for. These first 3 tricks eliminate the need for quadratic derivations entirely, letting you identify complex series through simple calculator steps rather than full-page algebra. Moving to Module 2, we bypass variables completely. Trick 4 is the integer substitution hack. When letters A, B, and C are in an arithmetic progression, immediately replace them with numbers 1, 2, and 3. If asked for A minus B plus C, plug those numbers in. 1 minus 2 plus 3 equals 2. You've solved it. Trick 5 handles word problems using hit and trial. Instead of building complex equations to find 2 unknown numbers, test the multiple choice options against the conditions given in the English prompt, like their sum or product. Trick 6 is the target product verification. If you are given the product of 3 numbers in a geometric progression, you don't need to set up terms like a over r, a, and a times r. Take the multiple choice options and literally multiply them together. 10 times 30 times 90 equals your target product of 27,000. Variables and word problems are usually just arithmetic hiding behind an algebraic disguise. You unmask them by plugging in real numbers. In Module 3, we extract data from advanced equations. Trick 7 is 2 equations elimination. If you are given 2 random terms in an AP, stack them and subtract. This instantly isolates the common difference and lets you avoid messy substitution. Trick 8 extracts the series from a total sum formula. If the question gives a formula for S sub n, like the one shown here, plugging in n equals 1 yields the first term, 8. Plugging in n equals 2 gives the sum, 22. To find the actual series sequence, look at how the calculation subtracts that first term from the S2 total. 22 minus 8 is 14. Now you have the first term, the second term, and the common difference. Trick 9 covers splitting an infinite geometric progression. When an infinite series has denominators that jump irregularly, it is actually 2 separate geometric sequences interlaced together. Split them apart and calculate each sum individually. Trick 10 simplifies special series. If a question asks for the sum of natural numbers or squares, test an option, like n equals 10, inside the standard formula to see if it hits the target sum. You never need to unravel an entire formula if you know how to surgically extract just the first 2 terms, or split the data into manageable parts. Module 4 covers high-value formulas. Trick 11 is the zero hack. Solving the pth term is q, qth term is p problem normally requires the full page of algebraic elimination you see here. Save time. The p plus qth term is exactly 0. Trick 12 is the arithmetic and geometric mean option tester. Finding unknown numbers from their means is faster by checking the multiple choice options. Add them and divide by 2 for the arithmetic mean, then multiply and square root for the geometric mean. Trick 13 is the bridge trick for inserting arithmetic means between 2 numbers. This calculation shows the specific shortcut formula, last term minus first term divided by n plus 1. Here that gives a common difference of 64, letting you step easily across the gap. Tricks 14 and 15 involve structural flips. Harmonic progressions are just upside-down arithmetic progressions. And as this logarithmic derivation shows, if you add logarithms to a multiplied geometric progression, it flattens out into a simple arithmetic progression. And the ultimate time saver is trick 20. If an exam gives you the ratio of the sums of two APs, this equation shows how to find the ratio of their specific terms. You simply replace n with 2m minus 1. These advanced properties are structural loopholes designed to reward students who know exactly what to look for. We have just covered the complete sequence and series syllabus using entirely structural loopholes and calculator hacks. Here are all 20 tricks matched to their specific exam triggers. Take a screenshot right now and use it as your review guide. High scores on this section come from identifying these structural loopholes early and applying the corresponding arithmetic shortcuts. Keep practicing these specific triggers.